Hello, welcome to Economics. I'm Isaac Temidayo. In this class, we'll continue our discussion on regression analysis. The last class, we were able to go through the types of regression analysis that we have, and also we have some discussions around the SRF, the FRF, and some other needful basics like that. Now, it was made known last class that we are just laying blocks, we are going to the foundation. So it is very, very important to take everything systematically, one step at a time. So it's very, very important you are following the classes from the first to the second, and this is the third class. Now in this video, we'll be going through the assumptions of the classical linear regression model, CLRM, the classical linear regression model. So the assumptions underlying the least squares method, they are the assumptions that underlies the least square methods. The least square method is basically the commonly used econometric technique in regression analysis. So it's very, very important we go through the assumptions that underlies this method. Now, we'll divide this class into two. We have the part 1 today, then we'll take the next video will be the part 2 of these assumptions. So we'll start with this. We have 6 assumptions to discuss today. 1, the linear regression model. The regressors values are fixed in repeated sampling. Zero mean value of the L term. The number of observations must be greater than the number of parameters. There must be variability of the values of the regressors, and also there is no specification bias. So we'll start now with the first assumption, the linear regression model. So the regression model that we are about to estimate using the least square method must be a linear regression model. And the last video, we explained the difference between linearity in parameters and linearity in variables. So the CLRM is basically concerned with the linearity in parameters. We are talking about a regression model, linear regression model. It is a regression model that is linear in parameters. That's basically what this assumption is about. Now, we have different models here on the board, different equations here on the board. The first one, y equals beta 1 plus beta 2 x squared. The next one, y equals 1 over beta 1 minus beta 2 square x, and y equals beta 1 minus beta 2 x. So which of these is a linear regression model? Which is linear in parameters? This is linear in parameters, this is not linear in parameters, and this is also linear in parameters. So we can always use the least squares method to estimate this regression function. We can use it to estimate this regression function, but we can never use it to estimate this regression function. So the basic assumption here is that there must be linearity in parameters. The constant term and the slope must be linear in parameters, this and this. So there must be linear in parameters. Unlike this third one, this middle one, it is okay. This is beta 1 raised to power minus 1, and this is beta 2 raised to power 2. So these are not linear in parameters. Basically, the linear regression model is the regression model that is linear in parameters. It may or may not be linear in variables, but the basic thing is that the parameters are linear, and that is the first assumption of the classical linear regression model. So we'll move to the second assumption here, that the regressor or the regressor's values, they are fixed in repeated sampling. That is, they are non-stochastic. You will recall that when we are differentiating correlation theory and regression analysis, we said something about the treatment of variables in both theories. Correlation assumes that both variables, they are symmetrical in nature. That is, the correlation between A and B is the same thing as the correlation between B and A. So there is no difference between dependent or independent or anything in correlation theory. However, regression analysis treats both variables in an asymmetrical way. That is, the dependent variable is assumed to be stochastic in nature. The aim is to predict the mean value or the average value of the dependent variable, while the independent variables, the regressors, also known as the explanatory variables, they are assumed to be non-stochastic in nature. That's it. So its values are fixed. So the aim is to predict the average value or the mean value of the dependent variable given fixed values of the regressors. or the explanatory variables. So in repeated sampling, the values of the regressors, they are fixed. And this is basically what we call conditional regression analysis. Conditional regression analysis. And what does this mean? You will recall from the example we gave in the previous video about household consumption as a function of income. That is, we are treating household consumption as a function of income. Now, if you take an example of, let's say, 5,000 naira as the income of 5,000 as the income of the household, you can always get different families that lives on that 5,000 naira. You can always get their consumption expenditure. An example now, let's say this X1 now is maybe 5,000 naira. Then I can get the average consumption of family A. I can get the average consumption of family B, and also the average consumption of family C, given this income. That's given this income level. That is, this income level is fixed. Now I can also move to another income level like X2 now. It is also fixed. With this X2, I can get the new level of consumption expenditure of family A, that's FE2, the new level of consumption level of family B, and also of family C. So here now you see that the values of the income, which is our regressor in this instance, is fixed, but over different sampling. That's basically what this assumption is about. That is, the values of our regressors is fixed over different sampling. So we'll still say something about this when we get to assumption 5. So it's very, very important to note that the values of regressors are fixed in repeated sampling. They are not stochastic. The third assumption now. Zero mean value of the disturbance or error term. Zero mean value of the disturbance or error term. You should of course still remember our discussion on this UI that it is the disturbance term, the error term, or the noise term. That's the different names for this UI. Now, the zero mean value of the error term or disturbance term simply means that the average effects of all variables that are captured in the error term, the average effect of every single one of them on the dependent variable must be equal to 0. Now, we assume, the assumption here is that we are not able to capture every single variables that might affect household consumption. We have the family income, we can have family size, and some all other variables that can affect this household, that can always determine the value of this household consumption. So the zero mean value of all other factors, that is their effect on this consumption, must be equal to 0, so that we can estimate correctly the dependence of this consumption on the income of the households. I'll basically call that this expected value of UI given xi equals 0. So that's what we mean by the average value of the error term is 0. So from the previous video, we said something about this PRF as the true value of Y, the true value of our consumption expenditure, is a function of the expected value of consumption given income plus the error term that we've captured every other single variables, maybe family size, or maybe governmental condition, environmental condition, everything. We've captured them here in the error terms. That's the PRF. Now, if you are taking the expectation of everything here, you take the expected value of everything that we have here, that is, this becomes the expected value of yi given xi equals the expected value of everything on this right hand side of the equation. So here we have the expected value of yi given xi as equal to, of course this remains, the expected value of this is still this, plus the expected value of this, the error term, ui xi given xi, and we have something like this. Now for this guy to be equal to our guy here, that is to estimate our regression function correctly, for this to be equal to this ui xi must obviously be equal to 0. If you collect like terms, you bring this guy here, you have expectation of yi xi minus expectation of yi xi, and that gives 0. So that simply leads us to this point that the expected value of ui given xi must be equal to 0 to be able to regress correctly. That's the reason for having this assumption. That is, the zero mean value of the disturbance of the error term, the average value of everything captured in the error term must be equal to 0 on their effects on the dependent variable. Alright, now then we'll move to this assumption 4. Now this says the number of observations must be greater than the number of parameters. Yes, the number of observations must be greater than the number of parameters if we are estimating, if you are using the least square method. So you basically call the number of observations, we represent that as n, while the number of parameters is basically represented as k. We represent this as k, y we represent this as n. So to use the least square method, the number of observations n must be greater than k. And why is this so? If you are estimating or you are trying to solve something around this, we have beta 1 plus beta 2 xi, you have yi equals this now. If you are trying to find the values of this beta 1 and beta 2, just single values, just single observation of maybe xi, yi, okay, let's call this x1, y1. This single observation on this cannot give you the solution to these variables. You have 2 parameters, so you must have at least 2 parameters to be able to get different values for beta 1 and beta 2. It's just like you are trying to solve simultaneous equations. So you need different values to be able to insert and get the values of the unknown parameters. So the number of observations, maybe this is x1, x2, y2, x3, y3. So we need at least, to estimate this number of parameters, you need at least not less than 3 different observations to be able to find this, to be able to find the values of beta 1 and beta 2. So the assumption here is that the number of observations must always be greater than the number of parameters. That's just it. And also there's one concept that we will learn as we progress in the class, this the degree of freedom. We call it the degree of freedom, we call it n minus k. So the n minus k is also very, very important. It's very, very basic to our understanding of classical linear regression. That's all. The degree of freedom is very, very basic to our understanding of classical linear regression model. So if our n is equal to k, we will always have problem with this least squares method. When we progress further in the class, we'll see something like that. So we assume basically that the number of observations must always be greater than the number of parameters to use the n square methods, the least square method, pardon. So the number of observation n must always be greater than k to use the least squares method. Assumption 5. There must be variability in the values of the regressors. So in the values of our explanatory variables, there must be variability in it. That is, the explanatory variables must not just take one single value. So if you are trying to, let's go back to our example. We are trying to estimate the dependence of household consumption, which is our y in this instance. We are trying to estimate the dependence of this household consumption on income. Then we must have different values of income to get the dependence of this consumption on this. So which means our x1 here must not be the same here at different observations. Though x1 values are fixed, that is the income values, they are fixed over repeated sampling. Being fixed doesn't mean they must take the same value. So that's what this assumption is saying, that there must be variability in x value. And why is it so? It will give us problem if we have different values for this level of income. Let's just say we are assuming 1,000 naira, 1,000 naira, 1,000 naira for different values of income. It doesn't even make sense. When you have 1,000 naira for one income level and 1,000 naira for another income level, then what are you trying to regress? One of the problems that this gives, if we have constancy in the values of our regressor or the regressors, is that now the mean value of our regressor will always be equal to the true value, to the value that we have. The mean value, that is this x, will always be equal to this xi if xi is the same thing. Now, if you take the income level as 1,000 naira, 1,000 naira in 10 places, 1,000 naira in 10 places, that is across different 10 observations, the mean value, of course, is still 1,000 naira. If you take 500 naira now, maybe 1,000 places, the mean value, of course, still remains 500 naira. Now, one of the formulas that we use, one of our estimators in getting the value of one of our parameters is this now. As our beta 2 cap is summation small xi yi over summation xi squared. So in subsequent videos, you will see how we derive something like this. So you don't just start to bother yourself too much about this now. In subsequent video, check that. Now this is also the same thing as this. We'll make that clearer in our coming videos. Now, if xi is equal to this, that is, if there is constancy in the value of the regressor, when you have this xi equal to its mean, 1010 places equal to 1000 naira. If this guy is equal to this guy, of course you should know that this the denominator here will be equal to 0, and you have something like summation xi this yi minus this all over 0. So this will be 0, this will be 0, this will be 0, this will be 0, and that is clearly undefined, which makes this impossible to estimate. So there must be variability in x values even across different sampling. So the regressor has to take on, of course, fixed values, but not the same thing. So fixed values doesn't mean equal values. That's it. So that's basically what this assumption is about, variability in the values of the regressors over repeated sampling. You combine this with this, and you get the full gist of how we treat the regressor, how we treat the values of the regressor. So the last assumption is that there must be no specification error. There is no specification bias. The model we are working on must have been correctly specified. So if our model is wrong from onset, then it simply means every other thing we are doing doesn't worth it. It is just a very good waste of time. That's just it. So what do you think will be the essence of taking or presenting a delicious meal before you that has been poisoned already? Of course, you can't eat that. So it's very, very important that our model must have been correctly specified. Now, I want you to recall something from the very first or second video that we had about introduction into econometrics analysis or econometric research. We said something about the methodology of econometric research, and the first point we made is that econometric research all starts from this point: specification of the model. All right. So okay. So I want you to recall something from the first or second video in our econometrics class, that we mentioned something about the methodology of the econometric research. It all starts from specification of the model, which is the most important thing there. I emphasize that the most important point there is specification of the model. So after you have specified the model, then you move on to the estimating the model. After you've estimated the model, then you move on to evaluating the estimate. After that, then you use your model to predict different values for that different values of the dependent and independent variable and everything that is involved in the model. So it's very, very important we specify the model correctly. And when you are specifying your model, 3 things to take note of. 1, identification of the dependent and independent variables. That is, which one will be the dependent variable, which one will be the independent variable. So the regression model that you will estimate will be obviously spurious if your dependent variable was made the independent variable. You take this example now, that if income was made the dependent variable and consumption was made the independent variable here, and I'm trying to get the dependence of consumption on income, and that's absolutely spurious. Okay, so having identified the dependent and independent variable, then also you pay attention to the a priori expectations about the sign and size of the parameters of the variables. So of course we said that in the second video. So it's important to note the a priori expectation about the sign and size. What sign does it take? What size does econometric theory tells us? Maybe anything about the size of the parameter of this variable in estimating the function. And also the functional form of the model, very, very important. When you are specifying your model, you need to get the functional form right. Maybe the functional form or the mathematical form of the model will be a linear one, or will be maybe an inverse function, or will be maybe an exponential function. Very, very important to get that. So the last point here, specification of the model, very, very important. So thank you very much for attending the class. We'll come to the end of the class. I hope you get the basic points here. We'll continue with our assumptions the next video about the CLRM. If you have any question, please drop them at the comment section. We'll attend to every single one of them. Please subscribe, turn on notifications, share with your friends and with everyone possible, and you get updates about our coming videos. Thank you very much.
Hope you enjoyed the video you just saw. If If you want more of our videos, please make sure you subscribe to the channel and click on the notification bell. Now, there is a way to enjoy to make the best of our YouTube channel, which is to go to the playlist section of every video or of every topic. So what you have to do is just type Economics on YouTube. When the page displays, make sure you subscribe. A bell button appears immediately, so you click on that bell button. Then go to the playlist section. So you're going to see videos, playlists, description, and all of that. So just go to the playlist section, and whatever topic you are looking for, look for the playlist and click on the video. Now, our playlists have their classes, the classes arranged in a very chronological manner. So if you want to see a class on ISLM, so it starts from the beginning, the simple ones to the difficult to the complex ones. So if you want to see a video on, let's say, elasticity of demand, so you start from what is price elasticity, so from there then to the basic ones, and on and on. So I'm just telling you that in case you really want to make the best of this YouTube channel. And there's also one thing that I want to add, which is that our YouTube classes may not be enough for you. You may want a regular interaction with the tutors and all of that. So what you just have to do is to check the description of the video. You are going to find a WhatsApp link. So, but before you do that, I really have to tell you that clicking that link is going to lead you to one of our schools. It's going to lead to some of our schools. So we have MOGE School of Economics on WhatsApp, and we make use of our YouTube channel to run the groups. So the classes are paid for, so you're meant to pay for them. So to join our Econometrics school, so that is 2,500 naira per month, and to join our Microeconomics or Macroeconomics schools, so that is 2,000 naira per month. We also have we don't have classes, or we don't have schools of mathematical economics, because Microeconomics has its mathematical aspects as well as macroeconomics. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching.